You can start a container with a single command. Map a port. Mount a volume. Pass in some config. Name it. Then finally the image. It works, but this exact setup now lives only in your shell history. What if you could just write it down once? First, the two words people mix up: image and container. An image is a blueprint, a frozen snapshot of an app and everything it needs to run. Docker run takes that blueprint and starts a living instance of it, a container. The image itself never changes. It is read-only, which means from one image you can start many containers. Blueprint versus the running thing. Hold on to that one. So write it down in a file called compose.yaml. Everything starts under one heading: services. Each service gets a name. This one we will call web. And we say which image it runs. That is the same Docker run from before, just saved and readable. But notice the indentation. In YAML, that is not decoration. Indentation in YAML is how it knows what belongs to what. Watch. Here, ports is indented to line up with web. So YAML reads it as belonging to services itself, not to web. The web service never sees its ports. Add two spaces and it snaps inside web where it belongs. Same words, a completely different structure, entirely from the spaces. Now ports, the line everyone copies and nobody explains. 8080:80, two numbers, and they are not the same number. The left one is the host, your machine. The right one is the port inside the container. The mapping opens a tunnel between the two. A request hits localhost, port 8080, travels across, and arrives at port 80, inside the container. Host port first, then container port. Always that order. Containers are meant to be thrown away and recreated. That is the whole point of them. But a database holds data you really cannot lose. And if that data lives inside the container, then deleting the container deletes the data with it. So you move the data out into a volume, storage that lives outside any one container. The volumes line just points the container at that storage. Now the container can disappear, and the volume with all of your data simply stays. Containers come and go. Volumes remember. Most real apps are a few services that need each other. Here, a web server and a database. Depends on tells compose the order. Start the database first, then web. One catch and it bites people. It waits for the database to start, not for it to be ready. And environment passes configuration in at startup. Passwords, URLs, settings. Each service. An image, its ports, its config, and its links. Here is the whole file. Two services, web and DB. On its own, it does nothing. It is just a description. Then you run one command, docker compose up, and the file wakes up. Web starts with its port open to the host. The database starts with its volume attached. One file, one command, the whole system running. Once it is up, you can look inside it. Compose PS shows what is running. Compose log streams what each service is actually saying. Real output, live proof the system is alive. Compose exec drops you inside a running container like any Linux shell. And compose down tears the whole thing back down. But the volume survives the teardown. Your data is still there. So, the mental model. A compose file is the named pieces of your app. Indentation is the structure. The spaces carry meaning. Ports map a port on your host to a port inside the container. And volumes outlive the containers that use them. One file, one command, a whole system you can actually read.